Markus Schwarz from Open Automation, and I wanted to personally introduce this project. In this project, you will learn how to make a Wi-Fi weather station using Arduino and the CC3000 Wi-Fi chip. You're going to build a simple weather measurement station based on Arduino, and we will connect this weather measurement station to your computer using Wi-Fi and a Node.js app running on your computer. So let's get into it.
Alright guys, so before we go any further, I will show you what is the general organization of the project. So how do the different parts of the project connect together. So really the center of the project is, let's say we draw here, is this Arduino Uno board, right? This will be the brain of the project. And connected to the board there will be two sensors. One is a DHT sensor for temperature and humidity, and the other one is a light level sensor. And connected to the Arduino Uno there will be a Wi-Fi chip, which is a CC3000 Wi-Fi chip. So this will be in constant communication with the Arduino board. And now we will actually access these measurements via the computer. So this big box here will be our PC. And basically what will happen is that the PC, via the Node app over there, Node, it will send requests to the Wi-Fi chip, which will transmit them to the Uno. And the Uno will answer with actually some JSON data, which will be sent directly to the Node app. And of course, on the Node app, we will not only have this communication part, but we will also have a nice interface so we can visualize the different measurements.
So I will now show you what you need to make this project. First, you will need an Arduino Uno board, which will really be the center of the project. Then, what we will use for Wi-Fi communication is this guy, which is a breakout board for the CC3000 Wi-Fi chip. To make all the connections, you also need a simple breadboard, just over there. Then the sensors. So first we will have a DHT11 temperature and humidity sensor. It is right there. To make this sensor work, we also need one resistor. I use a 1 kilo ohm resistor, but really you can use anything from 1 kilo to 4-5 kilo ohm resistor. And then for light level measurements, we use a photocell, which is this here. And finally, we also need a 10 kilo ohm resistor to go along with the photocell. And of course, I will use some jumper cables, I'll just put here, that we will use to make all the connections.
So now we are going to assemble the project. The first step is to place the CC3000 Wi-Fi board on the breadboard. Then you need to place the DHT11 sensor also on the breadboard. After that, simply place the 4.7 kilo ohm resistor on the breadboard as well, along with the photocell on the breadboard, and in series with the photocell, you will also place the 10 kilo ohm resistor. Then we'll take care of the power, so just put a black cable from the Arduino ground to the blue power rail on the breadboard. And now also place a red cable from the Arduino plus 5 volt pin to the red power rail on the breadboard. After that, we are ready to connect the Wi-Fi chip, so I will simply place several cables for each pin that we need to connect on the CC3000 Wi-Fi chip. So actually it's all pins except the 3.3 volts output, which we will not use for this project. So when this is done, you can simply connect the CC3000 Wi-Fi chip to the power, and also you can connect all the cables. So this is quite messy. I don't want to get the details here, but you can get all the details about the connections inside the corresponding article on the website Open Automation. So when this is done, we will actually connect the sensors. So the first sensor we're going to connect is the DHT11 sensor. So just put a cable going to pin number 2, put a red cable inside pin number 1. After that, put a black cable into pin number 4 for the ground and connect the pin number 1 to the plus 5 volts, ground to ground, and finally connect the signal pin to pin number 7 on the Arduino board. Finally, we are going to connect the photocell. So for the photocell, you are going to need also 3 cables. So one cable will go in the middle where the photocell is connected to the resistor. Then the other side of the resistor will connect to the ground with a black cable, and the other side of the photocell will connect to the positive power supply. So just connect this to the red power rail, black cable to the ground, so blue power rail, and finally the remaining cable you connect to the pin A0 of the Arduino board. Okay, so now I will show you how to use the Node.js app that will allow you to monitor remotely via Wi-Fi all the measurements done by the project. So, as you can see, I already went into the interface folder of the repository for the project. And you have several files, this app.js that we talked about before, and I will just launch Node.js by doing sudo node app.js, and let's see what it does. As you can see, it doesn't work, but it complains that it cannot find the module named Express. And this made sense as I didn't install it. So I will actually have to type sudo npm install, which is package manager for Node.js Express, and I will also need another module called arrest. So I do that. It will take a while to install all the modules. So it compiles some modules and then it's installed. So I'll try again sudo node app.js. And as you can see, now it works. It said it's listening on port 3700, so I will go back to my favorite web browser and actually type in localhost 3700. As you can see, it said cannot get slash. This is because I didn't define the main root, but I defined it in slash interface. And as you can see in the interface, I got my Wi-Fi, weather station, temperature, humidity, and said it's offline. And as you can see, it just updated, but it's still offline. So what's the problem? The problem is I actually don't have the same IP address as I defined before, because the IP address is attributed by your wireless router, so you will have to change it by hand. So we'll go back to the desktop, to the folder, in interface, public, you have this JS file. So it's called interface.js. So I will just open this one using my favorite text editor. And as you can see, it's called Wi-Fi, but it's the wrong IP address. So I just change it back to 3. And then I will quit this. Then back to my interface, I will simply restart the Node.js server, and then I will update this page. So I just updated the page, and I will wait for a moment, and now you can see it works. So it's put that the station is online, and you can see the measurement changing in nearly real time. So I think it's updated every 5 seconds or 10 seconds directly by Wi-Fi from the board. So I hope you enjoyed this project. To go further, the first thing you can do is actually modify the code, test it yourself, and then write some new code to integrate the light level sensor into the project. So it's really simple. It's the same as for temperature and humidity, just have to make some reading
from the analog pin of the Arduino board and then integrate this into the Node.js app. Of course, you can extend this project by creating more sensors to this board, and you can also have many of these boards in your home just by giving them several IP addresses. And then you can monitor all these boards from the central Node.js interface that you can program yourself. So please, as always, leave your feedback and comments below the video and subscribe to the channel so you can get all the latest news of our channel as soon as a new video is out, and I will see you in the next one. Hey guys, Marco Schwartz from Autonomous Automation, and I wanted to personally introduce this project. In this project, you will learn how to make a Wi-Fi weather station using Arduino and the CC3000 Wi-Fi chip. You're going to build a simple weather measurement station based on Arduino, and we will connect this weather measurement station to your computer using Wi-Fi and a Node.js app running on your computer. So let's get into it.
Alright guys, so before we go any further, I will show you what is the general organization of the project. So how do the different parts of the project connect together. So really the center of the project is, let's say we draw here, is this Arduino Uno board, right? This will be the brain of the project. And connected to the board there will be two sensors. One is a DHT sensor for temperature and humidity, and the other one is a light level